I've been involved in wireless for 30 years, and I've been following the low power WAN area for the last 10 years, or the last 5 years, and I've seen a lot of things come to the marketplace. So everybody has, all these technologies have a place to play, and just a matter of figuring out what's the right fit for the technology versus the application that's needed. When I was at Motorola back in the 80s, I had an opportunity to deal with what they called Intrac at the time. And we put in Internet of Things systems. It was called M2M at the time, and telemetry. And we actually put in devices in the field at the end of the phone lines where they were unreliable. We put mechanical devices, relays out there. This is before microprocessors. And we monitored the gas pressure in lines feeding the homes out there. And they had a 900 megahertz private frequencies for the utility industry. And they came back and brought the signals back to a translator that went into a mainframe. And they were able to monitor the values of the pressure in the lines and move them up and then move them down using the mechanical relays. Well, that was my exposure to what now we call the Internet of Things. And it's still the same thing. We just keep adding technology all along the way. So I am now learning about Weightless P, which is a protocol that's coming out of the UK, and it's being produced by a company, the first company to produce it. It's not going to be the last. There'll be many companies producing hardware based on this protocol. But they're based out of Taiwan. Their name is Ubiik, U-B-I-I-K. But in my research, I've done a lot of looking on the internet and look at the analysts and the researchers out there at the information they put out there. And I want to give them credit because it's awesome, the information that's available to us now just by clicking on Google and research. So if you start looking at the definition of the Internet of Things, you can find all sorts of definitions that are very elaborate and go into all these different aspects of the Internet of Things. To me, it's basically about remote monitoring and possibly controlling stuff. We're collecting information, we're analyzing it, and we're doing something. That's the idea of the Internet of Things. So the Internet of Things is a very complex, a lot of different people in the ecosystem, a lot of different technologies involved. But I break it down into 3 areas. We got devices out there, and you guys are very familiar with all the devices that out there need and what they need to do. I'm a wireless guy, so I keep up with the connectivity technologies that are out there. And then on the back end, that's a very rich environment with all the computer systems, cloud, and analytic tools and databases and whatnot that we need. So being a wireless guy, I'm going to talk about the wireless aspects of the Internet of Things. And in the old days, we had wireline and microwave and private radio. And cellular, 2G was probably a very good application, a very good technology for connecting all these devices out there. And it would still be used today if they would get the stuff, but they're taking them down, so we've got to find a replacement for them.
In the long run.
Yeah.
Really long run.
Yeah, exactly. GPRS worked really good for a long time for a lot of things. And then we've got the short-range technologies of Wi-Fi and the satellite. So when you start looking at the applications out there, it kind of breaks down to 3 levels now. If you've got more than a megabyte per second requirements, like video surveillance and automotive infotainment kind of things, then your technologies need to be high bandwidth capable. They're going to be using a lot of power, and it's going to be very complex and costly most likely. Then if you have less than a megabyte, but probably more than 100 kilobytes of per second requirements, then some of the LTE Cat-M and some of the short-range wireless technologies will work just fine for you. But the majority of technologies we're finding that are going to need less than 100 kilobytes per second of transmission, of data transmission capabilities. And that's where the low-power WANs, the Cat-M1s, the NB-IoTs, and the short-range technologies are going to be playing.
What is SRWA?
Short-range, multiple access. So it's another term for Wi-Fi and Bluetooth and BLE and those sorts of things.
Okay.
Zigbee, anything that's
short-range in its coverage. So if you were to break it down, and I won't spend a lot of time on this, but you can look, the short-range technologies have relatively short range, but their data rates can get up pretty good. Your cellular guys can get up real good data rates and get decent range. Low power WAN, however, is out here in a special area. And in fact, it is unique in that its range is relatively long compared to other technologies, but its data rate is very low. So this is not good for everything, but it's good for a lot of things that are coming in the future. LPWANs are long range by definition, but they're low power, not only in their transmit power, but also in the power that they use off their batteries. The idea is they're trying to extend the battery life at least 5 years, and they want to reach at least 10 years if they can for a lot of these applications. But the other distinctive part about a low power WAN system is that it needs to be low cost in the infrastructure that's put out there. And the cellular guys have got a real challenge because they're building their infrastructure, which is very expensive and very complex to cover large areas to support our smartphones. And that's high data bandwidth requirements. At the other extreme of that is our machine-to-machine requirements, our Internet of Things devices, which they use only a little bit of data every day, but there's billions of these devices. So their infrastructure and their approach is challenged to be able to support the M2M. And they've been really working hard to try to come up with solutions to that. And they're still in the process. We'll have to see how that works out. The other aspect of a low-power WAN system is that it needs to be scalable, because we're talking about 50 billion devices here in the near future. When? I don't know. But we're talking the next 3 to 5 years.
Always next year.
Next year.
Always.
But at some point, it's going to take off. And I think one of the reasons why it hasn't taken off is because we don't have good connectivity solutions out there. We also don't have good use cases and successful solutions out there to point to and go, that's successful, I want to do the same sort of thing. So until we get to that rhythm of having successes, we're not going to see a big uptake. But I think this low-power WANs will solve one of those problems here, and hopefully we'll get positive use cases out of here in the near future. The other aspect of it, there's two kinds of mobility that low-power WANs need to support. One is when you have a device in one network and you move it to another network, it needs to be able to automatically log into that new network. The other aspect that some low-power WAN systems need to support is the true mobility of a package or a device that you're tracking as it moves through an area or across the continent or whatever. Not all the low-power WAN systems can do that or should do that, but there are some needs for that. But the key capability of low-power WANs needs to be reliable communications, and that's very tough in these unlicensed frequency bands. So you need to have a lot of robust technologies involved to be able to give you reliable communication systems. And that's more what I'm going to talk about in a little while. And as we know, cellular will always have a place to play. There's always going to be a need for high bandwidth kind of applications, and where you don't worry about the cost, your application can justify that cost, and the power is not a problem for you. Cellular is the answer to that question, for that situation. Then the low-power WAN, the short-range folks, Wi-Fi and Bluetooth and BLE and Zigbee, those kinds of things, in the maroon will have a place to play as well. But the big application, or the most applications, will be for low-power WANs. We're talking about 60 to 80%. Depends on who you talk to about what the research says to them. 60 to 80% of them will be satisfied by low-power WAN requirements or capabilities, and that's because it turns out 86% of all IoT applications require 3 megabytes or less per month per device. And in actuality, if you look at the green pyramid there, 76% of IoT applications require 1 megabyte or less. So we don't need high bandwidth capabilities to support our smartphones. We need the ability to support short messages, but billions of them. So there's a lot of people out there bringing their ideas to market, their approaches and whatnot. I'm going to focus on 5 areas. I've grouped them together on Sigfox and nWave, Ingenuity, and then the cellular guys, LTE-M and NB-IoT, LoRa, which you guys are very familiar with, and then the weightless P capabilities. And just real quickly, so there's 2 kinds, there's several different ways to look at this. There are the licensed, let me go back. There's the proprietary approach, which the cellular guys have their own systems. Sigfox has their own technology. The Ingenuity RPMA technologies and Silverfox are all proprietary stuff. And then
There's
NG5.
Silver Spring. Is that what you were
It's
saying?
in there. Yeah. So they have their approach, and some of their approaches typically, well, not all. You got proprietary, and then you got open standards and whatnot. And the weightless is the open standard, and LoRa is almost there. Their physical layer is owned by Semtech, so it's not truly all open, but they license their technology to other chip manufacturers. So the MAC layer on top of it is open source, so you can use it as you see fit. So the other aspect to look here is that some of these technologies go into licensed frequencies, and some of them go into unlicensed frequencies, and some of them can go into both depending on what the need is. They're that versatile. So Sigfox, as we all know, and I won't spend much time on them.
Real quick,
Yeah,
what about in ocean?
what?
In ocean?
Don't know.
In ocean,
Yes, they make the
E-N-O-C-E-A-N.
devices that don't need batteries.
Right, but is that that's a proprietary
It is
radio, right?
Yeah.
Okay, it's close to that. You have to buy their devices on both ends.
Are they using energy harvesting?
Yeah,
Yeah.
Okay.
piezoelectric
Yeah.
energy.
I think we're going to see a lot more of that in the future. Jeff Smith talks about that that's going to be a very big support.
And
Like the ocean?
A very good technology for these kind of things. There's low power. As long as you can get energy from something, piezo,
Yeah.
wind, any kind of vibration and whatnot,
Yeah.
then you're going to be able to supply.
Also, RF,
And-
you're going to see devices that harvest RF.
Oh, sure.
Yeah, very interesting. So as most of us know, Sigfox has been around a long time. They created technology back 5 or 6 years ago, brought it to market very quickly. They've done a great job of marketing. It's the first generation of low power wind technologies. They've got a great following. They have over $300 million worth of venture capital backing this. And they're licensing their technology out to different infrastructure people throughout the world to put in their systems. They're very low throughput, and they're one way. When the transmitter needs to transmit something, it raises up, transmits its information 3 times, worst case, highest power possible, and then goes to sleep. There's no feedback, there's no confirmation of whether the signal got through or not. So they're hoping to have 60 to 80% of applications. Some analysts are saying it's only going to be good for about 10% of IoT applications because you don't have any kind of feedback downlink from the base station.
Is that because, based on what the analysts are saying, are they saying that because of no confirmation of messaging, or because there's no control path?
Because there's no confirmation.
Okay.
It's basically one way. They say they have some back channel, they have a downlink capability in
Yeah,
some
they have a
cases.
downlink capability.
Right, but it's not,
Right,
it's
but
not
it's
very
like, it's like a
robust.
broadcast down.
So Roman can
right?
talk
You
more
No,
cannot-
no, it's like
you
a
can't
web LoRa.
force-
You can basically
Okay.
reply to a message from the server, and so you can receive
So there's a
confirmation, I guess.
There's a handshake.
Yeah, so
No, it's, I mean, it's, yeah, basically,
It's
device sends
application level.
the data, and then it opens up an RX window during time
Yeah.
that the server can respond to that.
Yeah.
But the handshake would have to be done in the application, right?
Right. It's not built in.
So you said they've been around a while. Have they been profitable?
no.
I mean, their Series E funding, are they going to go to Z funding?
Probably.
If their marketing holds up, yes.
Yeah.
And it depends on how well they do in the marketplace. Because everybody in the IoT industry is challenged right now because IoT hasn't taken off. So they're spending all this money and they're not getting that much return yet. So it's going to take a while for this to
This is the, if you build it, they will hopefully come.
Exactly.
Yeah. So they've done a great job of
Which is
marketing
the only
themselves.
strategy that there is for these people,
Yes.
right?
That's been
What was
reality.
leverage
Yeah.
on the other, on the previous side?
That's one of the analysts.
Oh,
That's
okay.
information, I've given them credit for where I received this information earlier. So Enwave is similar to Sigfox. It's basically a one-way system. They've designed it to be mostly a one-way system because they want to get the maximum range and the maximum battery life. So they don't want to put a receiver in what they're doing. And what they found is that the parking industry is a great application for their technology. And they get excellent range. They put the little hockey puck in the parking space, and then they sense that an object is sitting above them, and then they transmit that out. So Paul Peck has done a great job of marketing those guys and getting them involved in that industry. So for their approach and their technology, it's a great fit for them. They've gotten some traction in that area.
So
Again,
that was
it's
a-
a very low throughput.
That was a great presentation he did, but I guess in my mind, and maybe you can help answer it, is why were they successful in the parking industry, whereas Sigfox wasn't necessarily? Was it just a marketing? I mean, technology-wise, they're very,
Because
very
of the
similar.
number of messages per day.
It was the number of messages per day?
Sigfox has a strict
And
140 messages.
They
per day.
couldn't back off of that at all within their own
Well,
protocol?
the parking, as I was explained to it, or as it was explained to me, the parking, you have to basically transmit when a change occurs.
Yeah.
And it's certainly possible for more than 140 changes to occur in one 24-hour
Per
period.
device, yeah.
Yeah, per device.
I guess Sigfox was not willing to make exceptions.
Well, I mean, and Paul is a good salesman too, so
Paul is very well connected, very good. So,
he was able to sell that deal.
That
you
was
know?
kind of my
But-
default assumption, but it's good to hear that. I mean, everybody's dealing with constraints.
Yes.
There's no one magic bullet, and it looks like Sigfox has locked themselves into specific constraints.
And part of it comes from Europe, where they have extreme restrictions over there.
Yeah.
And so they brought their technology to the United States, and they've had to rework it somewhat here.
Okay.
So they have their approach to things, and it's limited in what it can do. So Inwave's done a good job, and Paul Peck has done a great job at promoting them and getting them into that industry. Now, there's two kinds of approaches, basically, to the way LPWANs are created. One is represented by the spike. That's ultra-narrowband and narrowband. You're putting a lot of your transmit energy into a narrow part of the spectrum, and you're basically punching through the interference and giving yourself as much range as you can by concentrating all the energy in a narrow space. That's ultra-narrowband and narrowband technologies. The bell curve you're seeing there are spread spectrum technologies, and that's like Ingenuity and LoRa. And this comes from like World War II, or I'm sorry, the Cold War, when Qualcomm had their technology of spreading the signal out below the noise floor and hiding it. Our spooks, the other term for it, the organizations, CIA and
NSA.
NSA, those kinds of things. There's no term for it. I've kind of lost it.
Spooks,
Spooks
you
is good.
Right, Tom?
They would hide the technology.
Sometimes
They would hide the transmissions
sometimes
below the
called
noise floor.
TLAs,
Right. TLS.
Yeah.
Right.
three-letter agencies.
Right.
So those two kinds of technologies are one of the others what most of these groups are using. Ingenu uses the spread spectrum idea. In fact, two engineers out of Qualcomm who created this technology for the spooks back in the Cold War realized that Qualcomm is going to continue on their path of creating technology for high-speed communications for our smartphones. But they saw a need for communications to support the low-power WAN, the IoT requirements. That there would be billions of devices, but a lot of short messages that have to be created. So their technology needed to be modified. And so they did. They spent 300 person years creating a technology based on spread spectrum that would allow a tremendous amount of devices to be supported. And they used the 2.4 gigahertz Wi-Fi frequency range. And by doing some special techniques and whatnot, they're able to get much further range than what we expect out of Wi-Fi, which is maybe 100 meters at the most. They get kilometers out of it and get penetration into deep buildings. So it's a great technology. However, their business model is very challenged. They were trying to build out a public network for the whole United States and then license their technology to other companies to be able to put networks in other countries. And they basically have had to pull in their horns. Their CEO was let go back in August of this year, or June of this year, and the venture capital company is reorganizing how they're going to approach the marketplace. Technology is great, the business model is challenged. It's just so capital intensive to do a public network like that. So the cellular guys, as I said earlier, they've got all these smartphones they're trying to support with high-speed data. They're trying to figure out how to support the Internet of Things devices that are out there. And so they've got 5 or so different protocols out there. These two are the ones that are probably going to be the ones they adopt, at least for the near future. We don't know what 5G is going to look like. 5G, again, will probably be to support the smartphones, but there may be some aspects of 5G that will support IoT. We don't know yet what that looks like. So LTE-M is also called Cat-M1, or Electronic Machine Type Communication, EMTC. And then you got NB, Narrowband IoT, also called Cat-M. So they've got a lot of support for M1, Cat-M1. It's going to be easy for them to deploy that technology. It's basically a cut-down version of 4G technologies, which uses 20 megahertz of spectrum. Cut it down to 1.4. They're trying to improve the battery life of these devices, improve the range of them or penetration capabilities. They've cut down the speed of these devices, but it's getting a better fit for IoT type applications.
Now, they expect these to be a software upgrade on existing infrastructure.
Exactly. That's why it's going to be easy for them to do
Cat
that.
M1 specifically.
Yeah, M1. Yeah.
NB-IoT is not.
M2 is going to be very
Yeah. And so AT&T and Verizon are already deploying the Cat M1 out there. Orange and those guys are doing it as well. And then you see Telstra in Australia, TELUS and Bell in Canada are about to start, and they'll be doing the deployments here in the near future. And Sprint will do their deployment starting mid next year, according to the plans. And as we said, in narrowband IoT will follow that, but it's got a lot of challenges and issues with it trying to get it installed. There's an interesting thing. They wanted to come out with this NB-IoT standard quickly. Normally these standards take 8 to 10 years. They came out with it with just over a year. The way they did that, according to Nick Hunn, who's been following this for a long time, the 3GPP group, Nokia and Ericsson had their approach to the narrowband IoT protocol. It's basically a cut down version again of 4G. Very complex, but it would fit into the 4G networks pretty easily. The Huawei folks had bought Newell, which had a technology that was very different, very simple in its implementation. And they were promoting that in the 3GP group, standards group. The standards group put both protocols in the standard. And so now you've got some incompatibility issues, and they're testing right now to figure out how to solve that. They'll probably do it by having the chip guys put both protocols in the chip. And then when it's taken to a network, it goes, which one of these protocols do I need to talk? And that's what it will do. So we have to wait and see how they solve the problem, but that's challenges for them. And this is because they took their eye off the ball of IoT, then they focused on smartphones for all this time. So they got their challenges getting that set up.
So,
Yeah.
quick question, so Cat M1 is truly going to be a global standard where you can have Cat M1 device that you buy in the United States, and then you can take it over to China and you can use it over there and anything like that.
Theoretically.
All the bands are
Right.
the same band.
Exactly.
There's like 45 bands that the cellular guys use, so your bands may be different in every country.
So most of the modules support multiple bands, obviously.
So the Cat M1, the mechanics of it are going to be identical, but
Protocol.
what you're going to have to do is size it to whatever RF standard is allowed for that country.
Yeah, whatever region will have a different
And
set
that
of
was, and
frequencies.
that was what was brought out in that Link Labs webcast today, which I strongly recommend everybody go to YouTube because you can replay it. It was good information. It is creating we fall into the registration within the different countries and certification. And Link Labs, who has the devices, they're doing testing on, and they're identifying planning issues, and developmental issues, and design issues with these devices. And that's a little bit of concern for them, if you were to look globally and look.
Yeah, the economics of a device having multi-band radios is probably different than a cell phone. I mean, it's likely a cell phone travel and so forth, but for a cheaper device carrying an extra radio or extra frequencies or extra certification, you're carrying a cost.
Unless it's attractive.
Next month, I will bring the
Unless
very
it's attractive.
bizarre-looking antenna that goes along with the Cat 1M module. I've never seen anything like it before. It looks like a Rube Goldberg project, but it covers 14 bands.
Does it look like a finger, like a fist with one finger up?
Part of it does. You know, it's a surface mount. You know, it's a flat antenna, and so it has the regular flat part that you would see like on a cellular antenna, and then it's got this copper thing stuck to the side of it. I don't know. Have you seen this thing? I'll show it to you. It's really.
So that's
I
where
didn't know what it was at
Squarespace
first. I was
might
like, huh, that's interesting.
ubiquitous.
But it's because it's 700 megahertz and 1.7 gigahertz, and
What
so
range?
huh?
That's quite a range. So Roman's going to take over now and talk about LoRa. No, I'm teasing. He is our expert on LoRa. So just briefly, it's first generation technology. The physical layer is owned by Syntec. They're licensing out their technology to other chip manufacturers. The MAC layer on top of that is open source. The LoRa alliance of all the ecosystem partners involved in the LoRa WAN alliance are working on the next generation of the spec. And with that, they'll be able to improve the capabilities of LoRa.
It's
right
released.
now. What?
It's just released, yeah, 1.1.
They do that firmware over the air and a couple other.
Yeah, so in the past, they'd have the Class A devices. So they had the Class A devices, which would, when an event happened at the device, it would raise up and transmit, and then it would shut down, and the receiver would open two windows to receive information. Otherwise, the device would not receive. Class B does the same thing. It opens up and transmits, and opens for its two windows to receive something from the base station, and then periodically it raises its head and says, I'm open, do you have something else for me? With this new spec, it's giving them ability to download
No.
capabilities to
It's
it.
not part of that spec.
Okay.
No,
It's
they-
more
they
like
demonst-
about roaming capabilities.
But
Okay.
they've demonstrated it with the new class. I think I've seen a video where they're doing the firmware downloads, but you're right, it's not part of the actual spec
Yeah.
itself, but I think it enables
Right,
them.
so they're getting to that point. The point is, the alliance, the LoRa Alliance, is working to improve the spec. And they've got the building blocks there to do it. It's going to take a while though for them to get to that point where they become a truly two-way system and be able to do photos, firmware over the air downloads.
Yeah, it's a lot of times it's just not going to be really cost effective to do that.
Or you've got a 5-year battery life device that you get one firmware download and you're done.
Yeah, exactly. Yeah. So, and that's where it depends on your application as to what the technology is most appropriate. And LoRa is great for certain things in particular when they're trying to optimize the battery and be able to transmit information from a remote site, and they don't need to do that downloads all the time. So a lot of good things that LoRa, their business model is very ingenious. As Roman and I were talking about earlier, they do a great job of getting a lot of people involved in their ecosystem, and a lot of support there and a lot of innovation going on. So they'll continue to grow, and it looks like they'll be able to make it. So the weightless P, the WP protocol, is something that I've been following here for a while. It is the result of 7 years of research at Ofcom, which is the UK's FCC. Professor William Webb ran their Ofcom research group and looked at creating a technology that can use TV white space to be able to support Internet of Things devices. And I talked about this almost 5 years ago at the IEEE, and it's now called Weightless W for TV white space. And the idea was that TV channels are the same swath of frequencies around the world, and a lot of those frequencies are not being used. So if you could put low power transmissions on some of those unused channels, so like here in Dallas, if we were transmitting on channel 20 and channel 22, channel 21 is TV white space because it's not being used. As long as he could transmit low power and not affect our TV sets on channel 20 and 22 in my example, then that would be allowed. The England and the U.S. have approved that ability to transmit in the TV white space. Nobody else in the world, no major country, has approved that. So they had to put that weightless W standard on the shelf.
Well, how did the transition to what do they call it, ATSC, right? So they basically, all of the UHF bands got released in the U.S.
Well, they were always available, but nobody transmitted on
Right.
them. They were
But now
using
they're being
analog basically
reallocated.
at VHF where they could.
Right,
Low band and high band VHF. So when they converted over to digital, then they were able to use a lot of the UHF bands. They had to, because they had to get off of these existing channels to go up. So
Right.
you've got all the virtual channels, which are the old analog
Yeah.
channel 4, 5, 8, and that
Right.
kind of thing.
All that's empty right now.
It's now being transmitted on UHF, but they kept those numbers.
Oh, they did?
Yeah, I mean, kept the
Oh, no,
channel 4.
right.
Okay, but now they're
Yeah.
transmitting it.
Yeah. But isn't that spectrum being auctioned off, though?
Well, yeah, there's a lot of things going on because there's a great demand for more frequency. The cellular
Right.
guys on our smartphones are chewing up capacity.
Yeah.
And so they're trying to do, 600 megahertz is being auctioned off, was auctioned off, and I believe it's T-Mobile that bought the 600 megahertz. And great propagation capabilities
Sure.
and whatnot,
Yeah.
great penetration capabilities. There is some spectrum in there that is going to be possibly, I happened to keep it up with this last year, that will be available for for unlicensed use. So our low power WAN technology could go in there as well. 600 megahertz low power WAN technology would be awesome.
Yeah.
So we have to wait to see how much, if they grant it, and how much it will be.
Yeah, and potentially that could be a single band worldwide, right? Based on
It could
it
be.
coming out of old analog TV spectrum.
Yeah, the U.S. and the rest of the world are not necessarily in sync.
Really?
You know, we had this guy at the head office. Don't get me started.
Uh-huh.
So, anyway, yeah, it's possible because it's in the band where everything's. But
Right. This is the problem with all of these technologies, is you're either in Wi-Fi spectrum, or you're in 3 different somebody else's spectrum.
Oh, yeah, it's all over the place.
So,
So, the technology, the MAC layer that was created for Weightless W has been sitting on the shelf, but they have been looking for another band to work in. And in the interim, to keep things going, they adopted the N-Wave IP technology, the intellectual property that was donated to the SIG, the Weightless SIG, and they came out with Weightless N. And that's Paul Peck and N-Wave and all that kind of stuff. Nobody else is producing product on that protocol, so they more or less kind of just, okay, fine, and they're going to turn that over to Etsy and let them run with that and see if that grows or not. 2 years ago, somewhere along that range, a company called M2 Communications they're out of Taiwan, they have existing customers in Japan, China, Malaysia, Australia, the Asia area, doing relatively short range, 100 meters. Their radio technology would transmit out to e-paper
Displays.
this signage and the displays, and they would go on shelves or in product that's going through the manufacturing process, where you would normally check a box or you would write something on a piece of paper. They use this electronic paper. It's like Kindles, the e-paper, and so you can update it electronically, and it follows along, or if you change your sign on the shelf as to what's on that shelf or whatnot.
The only place I've actually seen that deployed is at, what's the furniture?
Nebraska.
Nebraska
Furniture.
Yeah.
It's I mean, I've known about it for years, but that's
Right.
the only place.
So the physical layer for that, with the way they were doing things, would be 100 meters or so. So it's short range, and for their application, it was great. But they were talking, M2Com was talking to the Weightless folks at the museum back 2 years ago or so, and said, look, we would like to get longer range. We have customers that would like to do that. You guys are looking for something else to put your MAC layer on. Let's talk. And so they came to an agreement, and the Taiwanese company at the time, M2Com, said, we'll donate the intellectual property for this radio physical layer and make it open source. Then you, Weightless SIG, add your open source MAC layer on top of that, and by doing that, they're able to get several kilometers range out of it. And in fact, they get 160 dB of link budget out of this combination and whatnot. LoRa is 150 dB.
Yeah.
So any place LoRa works, this will work as well.
Or better.
Or better, yeah, theoretically.
Nice one.
Oops. Okay. All right, so their niche is going to be industrial Internet of Things, Industry 4.0.
It doesn't matter.
And so it's going to be high performance in what they're doing. These are the 8 characteristics that they've really worked hard to focus and be able to solve or create a solution based on these ideas. So, of course, long range and low power is the key things. They want to be able to scale these things to handle billions of devices throughout the whole network. And then they've chosen to go on narrowband. They consider that the sweet spot between ultra narrowband and the spread spectrum guides. So it's 12.5 kilohertz.
Spectrum.
It's not spread spectrum. It's a narrowband. That's not there. So it's flexible also. And I'll talk about that more in a moment. It can go into many different frequency bands.
So it does a frequency hop.
It does frequency hopping as well. Yes. And it's bidirectional. And it's fully bidirectional, so you can do photo. You can do firmware over the air, FOTAs.
At
Firmware
what,
over
at
the air.
what speed?
Pardon?
Photo at what speed?
Up to 100 kilobits per second. And it's adaptive. So let me talk about that in a moment. I'll get to that what's going on. And it's synchronous. Synchronous means that it's a very disciplined system. And I'll talk about it in more depth in a moment, but basically it's assigning times for each of the remote devices to talk, as opposed to devices right now just randomly come up and transmit.
TDMI.
Yeah. And it's an open standard. So Ubic, with M2Com created another company, and a lot of their people moved over, and Ubic is now the manufacturer of this new Weightless P product. That's what I have up here. This is the base station for their starter kit, and this is one of the devices that we have. It actually has a temperature and humidity sensor on the board. This is a development board here, and it's transmitting to the base station every 30 seconds. And I'll show that. That's what was on the screen with the sine wave earlier. This was transmitting up every 30 seconds, giving a reading from that remote device.
So Ed, from a business standpoint, how does Weightless P, you're going to get to this later.
But this is a great question, Lee.
Okay.
Go ahead.
I mean, how does Weightless P not end up in the same position as Enwave, because it's a single manufacturer.
Not only for the
It's
time
open
being.
source, both of them open source.
Right.
Okay, but there's only one manufacturer.
For
right?
now.
For now.
But there's going to be other ones. Because this is a very robust technology. And let me get into that, and then you'll see why there's going to be a lot of people come along and adopt this thing,
Are
because
there
it
other
has,
people that have signed on?
I don't know that,
That
so I'm
have
not,
formally announced that they're gonna.
I've not heard that, no.
Okay.
I'm not that close to the Weightless P, the Weightless SIG, to know that. I need to reach out to them and find out, because I have worked with them off and on for the last 5 years. So I'll find out more. But it's open standard, and because of the things that it can do, their focus, the niche that they're going to go after with this technology is the industrial Internet of Things, the industrial 4.0 applications out there. So it's a narrowband, as I said earlier. It's going to be very scalable. The batteries will last a long time. If you want to go see a slide presentation that just is 12 slides long and has a great succinct explanation of what Weightless P is, do a Google search for Weightless P SlideShare. Jay Way put one out there, W-E-Y, Jay Way put it out there. It's a great little succinct explanation of what Weightless P does. So I'm going to kind of give it a view of it right now. So I talk about scalability. This system in a normal cell of Weightless P devices can handle 50,000 devices. And it can be less or more. It depends on your data model that you're supporting it at. But a typical cell site is 50,000 devices. As your capacity, if you have a cell site this big and you've got 50,000 in it, and you're running out of capacity, the protocol can allow you to turn down the endpoint power so that you shrink your cell site. So now you've got a small cell site. Now this cell site can handle up to 50,000, but you don't have that many in this cell. Then you can add more cell sites at 50,000 apiece. So it's very, very scalable capability.
Is 50,000 a real number or just an example?
It depends on, as an example, it depends on the data model.
Yeah.
Because if you have a high data model, and I'll get to that in a second, some of them, high volume of data, then you shrink your cell site to support 5,500 devices.
Right.
If it's a very skinny, like a meter reading every 30 minutes or whatever, then it can handle 92,000.
Okay.
So it just
Doesn't apply
depends.
to all these types of technologies, because remember, like when you're giving a presentation on Genu, that they're talking about like hundreds of thousands of nodes and stuff like that. Sigfox has talked about again hundreds of thousands of nodes going through it.
Yeah, well, and I'll show you why. The reason why I believe these guys can do what they say they can do, and we'll find out. When this stuff gets into the real world, is when we're really going to find out. And right now, there's 3 major projects going on in the Orient that could turn into millions of devices. We're waiting to hear back how those tests go. If those tests prove out, then we'll have use cases and we'll have real-world examples of how this technology works in these real-world situations.
So if you
Stay
have,
tuned.
let's say multiple gateways, is a device covered by all these multiple gateways or only one?
Only one. But it can re-register to another gateway.
Okay, so I guess they do adaptive power control to provide that scalability aspect.
Yes. Yeah, the base station tells the end device what power you need to be at.
And what channel to transmit on.
Yeah.
And
It's a very disciplined
and it's
system.
literally assigning a certain number of slots per channel.
Right.
So all the other technologies are, yep, you can support as many as you can until it doesn't work anymore.
Exactly.
Right?
Yeah, and the problem with LoRa is that it's a LoRa approach, so it raises its head, the end device transmits, and then hope it makes it through.
Right.
It listens, did it make it? If it doesn't, then it transmits again. And so it just keeps doing that until either the battery dies or it finally gets through. So that's not how this is. This is a very disciplined system. Something is assigned, everything is scheduled. And I'll talk about that more.
It's more like cellular.
Yeah, exactly. It has a lot of the cellular techniques involved with a lot of the complexity taken out. It's a simplistic protocol.
Does that require a temperature compensated oscillator on the node?
I don't know about that part.
Typically, Ultra narrowband require that, but narrowband might be.
Even with the times TDMA, it wouldn't require that? You probably have a pretty tight tolerance depending on how many
Depends
devices.
on how
you're
broad your
trying to-
channel is. If it's
Huh?
every half a second, then
Yeah, but that's the thing, I mean, in order to pack X number of devices on a channel, you gotta assign some pretty narrow time
yeah,
slots.
I think it's going to have to be more than one channel. I don't say 50,000 devices on the 12.5 kilohertz channel at all.
Yeah, and you're actually, in some cases with this spectrum that you're in, you can put 8 of these together, so you have 100 kilohertz worth of it. And that's where you're able to get the 50,000. It just depends on where you're at as to what the frequency rules are, the
Right.
rules for that frequency band.
So has anybody seen a deployment or a use case that actually requires 50,000? It's not a public network where you're trying to bring in lots of people. I mean, you look at an industry, if I'm looking at a manufacturing plant, if I'm putting 50,000 devices in that, I just don't see it yet.
Well,
Oh, no, not now, but at some point.
It's common.
Yeah.
Think of the Long Beach port. Okay, how many containers are there at any given moment?
Okay.
A couple of 100,000 containers.
Yeah, and that's a great example.
Yeah,
Right? That's just one,
Yeah,
you know, that
Yeah,
comes to
one place where you got a high density of something you're trying to track, and things
Yeah.
are moving all the time.
But I'm assuming I'd have multiple base stations there.
Oh,
Yeah, and this is built for the future.
Okay.
They've thought about this for a long time. I mean, this is 12 years worth of research and development that they put into this. Research at Ofcom and then 5 years of evolving the protocol at the Witness C. So they're looking at what it's going to take to reach, the whole point was to create something that can support the 50 billion devices and beyond. And that's why they put so much time and effort into it. It's taken so long to come to market because all the research they did to get to this point.
So
The last thing on, go ahead.
How many channels can a single gateway support?
Because it can, well, it's assigned one frequency for each base station. But you
Oh,
can change the frequency. And the frequency hops actually, if you want to.
Okay, so I guess the devices, basically all of the devices that are connected to a single gateway are using only the same frequency band or channel. And then I guess they will hop with the base
Right.
band.
Because this thing does scheduling, it will tell the remote device, I'm going to put you on this frequency hopping schedule. And this is your time slot when I'm going to expect you to speak. And then there are paging channels, and I'll get into that in a moment, but there's paging channels available also in this 100 kilohertz, so that if the base station needs to tell the end device, I need to change things, it pages the end device wakes up and says, what do you need? And it reschedules it. Changes the frequency hopping schedule, it changes the timing, whatever that kind of stuff. So it's a very disciplined system, very scheduled.
So potentially, if you wanted to build a higher capacity base station, you could put multiple RF front ends on it, basically. And
Absolutely.
it would have more of the one frequency available to it.
Right, and this is just the beginning. I mean, they're just getting off the start. They've shipped out 40 starter kits to 20 countries around the world. They've got 3 major proof of concepts going on. They'll probably have 7 before the end of the year. So they're working out of the owner's resources right now. They're going to get Series A here sometime after the first of the year, probably. And then they'll be able to beef up and then do things to improve and add to the capabilities of the systems. So right now they're starting off with the basic capabilities with the base stations and the
So that's why the base station RF is pretty simple. I mean, if you had a chance to touch the Sigfox gateway, I almost burned my hand.
Yeah.
Wow, is that right?
Yeah, it was like made of, I guess, aluminum package, and I
Yeah.
touched it. I was like, ah.
Yeah. Wow. But get rid of the heat. Boy, this big generator helped a lot. So anyway, the last thing on this slide I want to talk about before I go into the other ones, security. So they were thinking from the very beginning, this needs to be highly secure, and they have mutual authentication. So when a device wants to talk to the network, it has to authenticate that this is the actual network. I don't see a man in the middle. There's not somebody spoofing me. I'm going to actually connect to the right network. Same thing, when the network says, I see a device and he wants to talk to me, it verifies that that device is what it's expected to see. They have some sophisticated ways of doing that kind of authentication. They also, because it's fully two-way, they can negotiate what cipher, what security that needs to be implemented in this communications link between the two of them. And then, what is it? Extensible authorization protocol, generalized pre-shared keys. That's a very sophisticated security technology that they're employing in this authorization. Yeah, I tried to learn this afternoon. Sorry it took me so long. Yeah,
It's easy for you to say.
yeah, exactly.
It's
And
not Gaussian phase shift keying.
Yeah, there you go.
Nope.
No, that's not what
Looks like
this
it.
is.
It looks that way.
Right. But yeah, you can read it up. And then AES 128 and 256 in some applications, whatnot, for other encryption capabilities. So they took security very important, very seriously at first. Oh, there we go. I did it right. Yeah, and AES then followed us from OB.
Is there any kind of, like with the standard module? Is there any type of hardware authentication chip built into it? A secure element? I mean, I obviously it can be added. I didn't know if that was something that was baked in.
Not to my knowledge. Okay, I'm a systems level guy,
Yeah.
so I don't get into the device level that often, and I'm trying to. Marty help me out this next week. We'll dig into it. I've got a lot of the documentation, and I've got access to this stuff.
Yeah.
I'm just not a device guy.
I think it's an implementation detail.
Sure, sure. Yeah. I didn't know if they made it a requirement, if they're talking about security, you know, to put a
Don't know about
secure
that,
element.
but I do know that if you come Friday,
Yeah.
Kurt Kelly and Robbie will talk about their security blockchain, and Robbie has access to a crypto processor
Mhm.
that he's inheriting from someone that's a friend of his. Very brilliant at the time. So anyway, we may be able to use their technologies and whatnot along with this radio protocol to create some solutions. We'll see. We'll find out more on Friday when they give us an update. So the idea of capacity is enabled by several different aspects of the technology and what it can do. One is Weightless is very efficient in what it does. It uses the 12.5 kilohertz and it gains those together where it's appropriate. The synchronous idea is that you're assigning spots for each of the devices. I'm going to talk about more here. So you're assigning locations, but you're also scheduling the hopping frequency, when the device can talk, and what paging channels to use. So there's many different things that it's scheduled. So it's a very disciplined system as to being just one that allows the devices to transmit whatever they want and then have high packet loss later on. Now, this is where I was talking about, if you're using a very slim data model, then you can get up to 92,000 devices in the cell site. If you're using a very heavy, lots of transmissions back and forth, then you're talking about 5,500 devices in the cell site. Paging channels, as I said, and then you can schedule the resources. And by doing 12.5 kilohertz, your throughput is like 49 bits per second per kilohertz. So it just depends on how you look at the technologies as to how efficient they are. And this is discipline, and everything is scheduled in as to when it has to happen, what channel it has to transmit on, and what the hopping frequency is, that kind of stuff. Paging is scheduled on.
So what is the modulation on here? Is it frequency shift?
It is
phase shift?
Gaussian,
It
Gaussian,
is GPSK?
yes, and what's the other thing? Let's see. I'll get to it in a minute because it's listed here somewhere. I'm trying to remember what, but it's
Forward error correction right there.
yeah,
Yeah.
and convolutional coding. So they reduce the amount of retransmissions required because they're able to reconstitute the messages very
But
easily.
it's not a quantum, right?
Well, there is a quantum aspect to it. So let me get to that point. I think it's listed on another slide here in the future. I'm trying to remember what it is. The other thing here is that, well, I was going to say something. I'll think of it in a minute. This is very adaptive. So not only does it all do the forward error correction, the convolution coding and whatnot, but the encoding scheme is modified depending on what the environment is. So the end device is looking at the RSSI, the signal strength of the base station, the gateway coming down to it, and it then calculates what its response needs to be approximately to go back.
So like, is it adding extra error correcting bits and things like that? Is that what you mean?
No, what I'm talking about is the fact that if it can't what it's trying to do is optimize and shorten the transmit time as much as possible. So it not only looks at the power that it needs to transmit back at, but it also looks at the encoding scheme. Can I transmit at 100 kilobits per second, and therefore my transmitter is only on for...
So it changes data rate. Adaptive.
Exactly, it changes the data rate. It's adaptive data rate. And if the encoding scheme is changing to change that data rate. But it's optimizing to keep the transmitter transmitting the least amount of time for the least amount of energy. So you maximize the battery as long as you can.
So it kind of bursts.
Yeah, it's trying to... Yeah, exactly. It's fast. It'll transmit as fast as the environment will let it.
But I think the key there is it's not spread spectrum. So if you get in a noisy environment, you run a little bit different risk here as associated with somewhere else. you may miss that message, but then in the application layer, you retransmit, you change channels, you adapt around it that
Yeah,
way.
and it's got automatic retry requests, so ARQ is built into this thing.
And presumably it's gonna learn if it's got noise on a certain channel and just avoid it.
You can blacklist channels, yeah, exactly.
Unless
So
the
that you
hackers
don't-
that are following you and
Exactly.
jamming you.
Yeah. So it's totally two-way. You can do photo, the firmware over the air. You can do any kind of updates that you need to the remote devices. It's built in. That's one of the things it does right out of the box. Reliable uplink and downlink capabilities.
What is paging in this context?
So it's reaching out. So if the base station needs to talk to the end device out there and say, I need to change your frequency hopping schedule, it will page it and wake it up. So I got something for you. And then the device wakes up and they've agreed that they'll connect and do an actual transfer of information.
So
back.
does
They'll
that
do a
mean that
handshake.
all the nodes are always listening for that paging, or are they listening periodically for the paging?
Yeah, and I haven't got into exactly how to do the paging. I think it is as the header is going through, this periodically is just looking to see, do I see that change in that header at that point that would tell me I need to wake up.
It's kind of like Class D, I think.
Right. Or it sounds like literally how a pager used to work.
Well, exactly. That's why it's called paging, because
Yeah.
there's just,
So the base station transmits for a second, and all the devices wake up for 5 milliseconds every second.
yeah, and I think we've reduced the time
Yeah,
considerably.
yeah.
It's, milliseconds
Right.
that it's
But
looking
you don't
at.
really care how long the base station transmits. It's not.
No, it's got plenty of power.
Right.
Yeah, it can transmit all at once.
As long as
It's
it
the end
doesn't
device
burn
that
your
you're trying to.
hands.
What's that?
As long as it doesn't burn your hands.
Well, exactly.
Like some people
Sigfox's
care.
branding strategy?
Some literally
It's
branding.
best to listen on so many channels at the same time, so.
Yeah.
So,
Here, touch it.
Touch it again.
and it is open
Touch it.
standard.
Don't touch it.
Yeah, and so there will be other people out there. UV, because of their history with M2Com and the people that came over, they're like the master chef. They already understood the existing physical layer that was there. They need to understand the MAC layer and then create the whole protocol stack based on those two things. And so they're the first to market. There'll be other people that come out.
Is weightless P and weightless W the same protocol?
The MAC layer is very similar.
Okay.
Okay, it's been improved some. because
Similar,
you've got
but
a-
not identical.
Not again identical, because you've had 5 years
Yeah.
of evolution and they've realized some things they needed to.
And weightless W hadn't moved in 5 years.
No, because only the US and the UK have allowed it, so they put it on the shelf. And in actuality, weightless W was, a lot of that was contributed by Newell. Newell was bought by Huawei.
Mhm.
So a lot of the ideas that Newell contributed to weightless W has gone with Huawei. It is now the NB-IoT standard. How much, I don't know. I just know there's history there. Don't know how exactly all that
It
happened.
was at least influenced.
Influence, right. And that's why the Huawei system is very simplistic. It's a very uncomplex, uncomplicated type of approach, whereas the Ericsson Nokia is a 4G derivative and still very complex. So the chips will always be very complex and expensive. What they've got going for them in the cellular industry is they've got economies of scale. There's over 800 entities in the 3GPP standards group, and they all want that to be successful. So at some point they'll have economies of scale and be able to drive the cost down for those NB-IoT chips. It's going to take a while. So there are 17 critical factors. This is like a checklist. If you're looking for a technology for a certain application, you ought to go down this list. If you do a Google search for 17 critical features, weightless P, you'll find the whole list. But it's basically the things I've talked about so far. The kind of channel arrangement, the fact that it works in all these different frequencies, 169, 433, 475, 12, 780, 868, and then the 902, 928. But it can also go into licensed frequencies. So it just depends. If you have a nationwide frequency band that you want to deploy this, you can do that. So that's how flexible
So-
this is.
So, does it change like duty cycle requirements for these different frequencies?
Yeah, the
Probably
rules are
based on
different in every
country,
region.
right?
So, and that's partly why it's nice that this is adapted like it is, because it depends on what is allowed in your particular country.
So it will
And of course-
automatically adapt to,
No, this would be right now, because we're just starting off. This would, you would, and this equipment is built for 868 or 902, 928. It's a
so it's a
software-defined
different,
radio.
yeah, so.
In the future, they'll be able to tune it to these others. That's not what this is designed for right now.
And not
But
a
the spec
single one of
supports
those
it.
bands is available worldwide.
No. No.
It's
And
so
that's why,
simple.
that's why 2.4 gigahertz was so
Of course.
interesting. If you could get
Yes.
something to work in there, and I think Engineer
Right.
has an excellent technology for that band. And then
TV,
TV white space frequencies have worldwide coverage.
but
So,
obviously not regulatory
but still,
support.
exactly right, the regulations are what's holding it back. So the other specs, it's very synchronized, has paging, forward error correction. It can re-register on a new network, and every message is fully acknowledged. Then narrowband works in licensed or unlicensed frequencies. When it goes to sleep, it uses less than 100 microwatts of power. So it's a very low usage when it's not transmitting. And then it optimizes minimal amount of transmission time if possible. And then AES 128 and 256 for authentication, and then FOTA, the firmware over the air.
So FOTA is dedicated basically for each device, or it's a group?
It can be group, it can be a multicast. I'm glad you brought that up. Yeah, so you can do a multicast out to a group of devices and download the firmware up at one time. Last thing is that the interesting part is that open source, it's royalty free. So if you join the Weightless SIG, it's like $1,400 a year to be a member of it, and you get access to the spec. And then you can create all the products you want based on this the Weightless P specification and not have to pay royalties on it, licensing fees. It's a Franz Z licensing arrangement. And that's pretty much it, just a review of it's bidirectional, adaptive in both the power and its data rate, highly scalable, it's a disciplined, a very synchronized network, and it's open standard. The cons, they just started shipping hardware in August of this year. That's the 40 starter kits and the 3 major proof of concepts that could go to millions of devices. And their plans are for 7 total before the end of the year, is what I understand.
So they're selling the module or the chipset?
The module, the radio module. So people like you then can put that in devices and create. It's a substitute for
When
LoRa.
are they planning to have a production plan?
So they're trying to satisfy the demand because of their existing customer base and their reputation and the things they've done in the past, those people have come to them and have swamped it. It's only a 25-person company right now. And they are trying to satisfy the request, the need for information, and supplying equipment to these guys out there right now. They're working on getting Series A. They expect to get it someplace after the first of the year. When they do, they'll be able to beef up and be able to improve their support, improve their manufacturing, and increase the production of
Are
capacity.
they making, well, they're not a fab, but I mean, do they design their own silicon? Or are they using somebody else's silicon and building a module from
I
it?
don't know for a fact. I believe they're building their own. They've been doing this for the last 10 years or so as M2Com. And so this new company that basically spun off and moved a lot of people over are doing that. So it may be coming out of
So do they
M2Com.
consider themselves a semiconductor company, like a fabulous semiconductor?
Well,
No,
I think for this to be successful, you're going to have to see more available production. You know, Paul talked about Analog Devices building these configurable SoCs,
Yeah.
and they went that direction because they saved the $2 per chip licensing from LoRa. So if this became available in a generic Analog Devices solution or something like that, I think you have more traction.
Yeah, and this is early stage. So they got a couple things working against them in that it's taken them so long to come to market. But the market hasn't taken off. So they're not out of the game yet. If they can get their act together, they can increase the production. They can get the Weightless group can get other companies producing a product based on this. Then we're going to have a richer ecosystem and choices then for developers and systems integrators to put
So
together.
this is where, you know, for what it's worth, this is where LoRa has a big head start on
Absolutely.
everybody. You know, I mean, yes, Semtech ultimately does own the IP, but there's at least 100 companies that make LoRa something. you
Right.
know. And Sigfox is actually, I mean, they're nowhere near where LoRa is, but they're aggressively out getting people to start making modules and making Sigfox devices.
Yeah. So these guys have their challenge.
Yeah.
Yeah. So we'll have to wait and see. But as far as the technology goes, I believe this is an excellent technology that has the chance because it is an open source and if it gets adopted, it's not too late.
Right.
But if they have to do the right things for the next 6 months, a year to be able to get momentum and be able to do that.
If they can produce a base station, they'll be ahead of the world.
But it's a star topology protocol.
Yeah, oh, that's what I had up there a while ago, was that,
That's exclusively Star, or they have the capability to support repeating?
they don't talk about repeaters yet. I mean, they're focused on just trying to get product out the door and satisfy the customers they've got right now. But it is a star technology in the fact that you got your base station talk to your end devices back there.
Right.
And in my demo here, the base station actually talks to the Ubic cloud, but it doesn't have to. Anybody's computer system, cloud or analytic tool, whatever you've got, can be connected directly to all the base stations. So this is the business model is systems integrators or solution providers can buy 1, 10, 100, how many base stations they need to solve their particular problem. So it's not a public network, you don't subscribe to it, you don't have to, if you have a need for a coverage area in a certain area, you put the base stations in to do that and to reach into the buildings where you need to go. You don't have to wait for the carrier to do it for you. So it's much like LoRa in that business model.
Do you know if there will be public networks?
It can be, so
But do you know if there is any?
No.
It's too
No,
early
there's
to
no
do
time.
that.
So, someone like a Senate, someone that's a systems integrator that wants to do that sort of thing, that's a real risky proposition
Sure.
to take that on.
There's no ecosystem.
Right. So, it's gonna be a time before that happens. But, and this is more applicable to industrial applications, industrial internet IoT, where you've got complexes, you've got campuses, you've got a manufacturing plant, you've got the port you're talking about, you've got BNSF rail yard,
Yeah.
you've got some place that you're trying to cover and it's too big for Wi-Fi, and it doesn't make sense to buy into a cellular network for the whole United States.
Right.
So it's that that special use case. All right, so if you're interested, you can go to the Ubic website, wbiik.com, and order a starter kit. So this is my end device, which is an evaluation board that's hooked up for power, and it's transmitting to my base station. And the base station then is plugged in. And thank you, Pete. Pete got the permission to pass through the firewall here.
Oh, wow.
And then I'm connected to the Ubic cloud in Taiwan. And then my computer here is looking at the dashboard of the Ubic cloud. And it's showing every 30 seconds, this remote device is transmitting out temperature and humidity. I haven't had a chance to figure out how to load the translation so that I could actually display the temperature and all. But you can tell that it's transmitting up. This is fully two-way.
You know what? As long as
so-
I've been in this industry, that's still freaking magic.
Yeah.
You know, think about that.
It's
There's a
RF.
device sitting on that
Yeah.
table that's transmitting a packet to Taiwan right now, and we're seeing the real-time results on screen.
Yeah.
Are you kidding me?
I know.
Completely impossible.
50 years ago, this would have been completely impossible.
Well, I mean, you can
Right?
check your weather, you go up to a satellite from your phone.
No
Just
doubt.
Don't even look out the window.
Yeah.
Yeah.
Let me look from the
Oh, yeah,
satellite.
but it won't change
Oh.
tell it. No, see, so this has an LED on it that can do 8 different colors. So it's blue right now. So I can do a transmission from the base station down to the device. And I'm going to change it to white. It's blue now, so I'll do white. And that's the device. It'll take about 3 to 5 seconds for it to transmit down. For it to change.
There it is.
Ta-da!
Right.
So I can do
Hey.
that.
We got a downlink.
Hey!
Yeah.
All right, so it's fully two-way. So that's it.
That's why the server's not in China.
The only thing I wanted to show you otherwise, that's my family. My grandson just had his three-year birthday last weekend, and he wanted all of us to come to superheroes. So if you don't recognize me, then go with that. My son is an Iron Man, a runner and all, so he went as the Flash.
Of course.
My wife didn't know what the Flash was, so she didn't get it.
No way. I like it. I like that y'all have 6 packs.
Yeah, that was pretty good. And so my wife went as Wonder Woman, so it was great. So anyway.
Nice.
So any other questions, guys? I appreciate you letting me come today.